scuola di ingegneria aerospaziale della Sapienza è in tutto il mondo chiamati EduSat, Lares e Tigrisat. La scuola ha lanciato nello spazio
As we orbit the Sun, Landsat 8 positions itself to capture imagery in direct sunlight. It's called a Sun synchronous orbit. And it happens every 99 minutes, and about 14 times a day. As Landsat travels from the North Pole to the South, it's capturing data over a 115-mile wide swath. So every day we add 14 swaths. And over 16 days, we complete a full picture of our planet. And we start the cycle again to watch global changes as they happen.
When we investigate land cover using the instruments aboard Landsat satellites, we collect sets of data for different wavelengths. Some are in the infrared, and others correspond to blue, green, and red visible light. We can combine any three of the images to create different depictions of Earth's surface. What you're seeing now is a Landsat image of Florida, made with data from the blue, green, and red visible wavelengths. We call this a natural color image because it looks approximately like what we would see with our naked eye if we flew far above Florida. But we could choose data from other wavelengths and map them to blue, green, and red colors to highlight different features of the land surface. With this particular depiction of the multispectral data, for example, we can see much greater contrast between trees and shrubs in sawgrass marsh than was apparent in the natural color image. We call certain combinations of wavelengths false color images because they do not replicate what we see with the naked eye. Yet they allow us to create images where we can highlight or enhance different surface features. The following depiction approximates the type of image that you can get from color infrared film. It turns out that vegetation, growing active vegetation, reflects a lot of light in the near infrared, and so areas with healthy growing vegetation jump out as red in these images. You can easily distinguish the healthy agriculture more clearly than you can in the true color image. Here you can look at the three different depictions of the multispectral data we use to create these images. And you can see how the surface cover appears different with some features enhanced in the different depictions.
La scuola ha
The data received by ground stations from Landsat looks very different from what users download. First, the data is received in 1 gigabyte chunks that are recombined to form the long swaths of the satellite's path. Odd and even sensor chip assemblies send offset and overlapping strips. Gain and bias adjustments correct for differences between assemblies as well as each individual detector based on calibration data. Each band is also brought back into alignment and the data is rotated to prepare for placement in its final scene. From here, ancillary data detailing the position and orientation of Landsat 8 is calculated with elevation data about the ground. This model traces each pixel in the final scene back to a 4x4 block of pixels from the raw data. Those 16 values are weighted to produce the final radiometrically and geometrically accurate pixel. Finally, a library of ground control points are compared to the points in the scene to evaluate how accurately the pixels align. This measurement is the scene's RMSE value. The number of meters an average pixel is off. Landsat's best quality scenes, Tier 1, are within 12 meters, about a third of a pixel. 90% of new scenes meet this mark.
And managing input costs, farmers need more information on their crops than ever. For this, they turn to trusted crop advisors to get the most high-quality, affordable information to help serve their growers can be difficult. This is why we've designed the Planet Labs Monitoring Programs for Agriculture, a cost-effective satellite imaging solution for comprehensive, regular coverage of large agricultural areas. Here is how it works. To get started, select an area of interest. This will be the area that you receive imagery of throughout the growing season. We then collect your imagery multiple times during the growing season. All imagery, including Landsat 8, is stored in our cloud environment shortly after acquisition. You can then access the imagery through a web application or API. And finally, you can create and distribute an unlimited number of information products for use in all of your applications. So how do we do all of this? Our constellation of satellites captures more than 5 over your area of interest multiple times throughout the growing season. With the combination of bands used by the Rapid Eye constellation, especially the unique red edge band, you get the information you need to help growers farm sustainably, increase land productivity, and reduce input costs.
Success